Alright guys, I hope that last question went okay. Now we're on to the third question. We've got a triangular prism here. And we're going to start off by finding the exact length of AC. Now, as you can see, AC is that line across there, yeah? So if I'm looking at a 2D shape, then it's the line between A and C. So it's this diagonal one. So I'm going to make it red. So it's this one along here. Now to see that one, is it going to be easiest for us to draw this side, or top down? Top down's definitely going to be way easier, I think, for our purposes for this video. So we've got AC and we're going to draw this top down. So we've got D, C, B, and A. Going to connect them. Your diagrams, like, I really recommend you try hard with your diagrams, and I also recommend using different colours. I always use a different colour when I'm doing writing in the one I want. So the length between CB is 2 centimetres and the length between AB is 4 centimetres. So you can see that this makes a right angle triangle. So AC squared is, because AC is the hypotenuse, equals 4 squared plus 2 squared. So AC is square root of that. So AC is, well, that's root 12, which is, oh no, that's not 12, gosh, that's 20, isn't it? 16 plus 4, 20. Which is root, well, that's 4 times 5, which means I've got 2 root 5. And when they say exact length, that's telling you they want it in a third. Number 2, we want AF, which, looking on our diagram here, is this one cutting kind of across. So let's actually look at that in 3D. I'm going to get rid of this line that we put in for this one. Okay. Now AF is the line going from A to F. So see how it's kind of cutting diagonally across there? So, I mean, looking at it sideways isn't going to help. Looking at it frontways is probably not really going to help. It's going to help more if we also put in the line that we had before from A to C. Oh, sorry, no, I want to do an interval, A to C. And let me make that one blue. And then if I also make this one blue, so these blue ones, that's the triangle I'm going to draw, A, C, F. So I've got A here, C here, and F here. So AC I already know, it's the red one that I did just above. CF we know, we've been told that. Sorry, I'm just trying to colour code these some way. I don't like the fact that I used pink. And then AF is this green one. So AC we figured out it was 2 root 5. CF we know it's 2. And again, we're after the hypotenuse, so we've got AF squared equals 2 root 5 squared plus 2 squared. So AF is the square root of this. So it's the square root of 2 root 5 is 4 times 5 plus 4, so it's the square root of 24. So that's the same as 4 times 6. Yep, 4 is the biggest square number that goes into it. So we get 2 root 6. So that's the exact size length of AF. Now they want the angle ACF. ACF is this one. It's 90 degrees. I wonder if they stuffed up. No, because C asked for angle AFC. Oh, so that was B. So C, angle AFC is this angle up here. So the opposite length to it was 2 root 5. The adjacent length of it was 2. We could have used sine and cos and just used, whatever length we got there, 2 root 6, but why bother? So theta equals arctan 2 root 5 over 2. Oh, I don't have my calculator. Hang on. I'm trying to be quiet because Miss Mitchell and Miss Barrett are here and I don't want to disturb them. So that's going to come out as, putting in our calculator, we've got 2 root 5 over 2, didn't bother simplifying. We've got 65.91 degrees. They want it to the nearest degree, so we're just going to round up. That's question 3.